Okay. Yep. There we go. Sorry, things aren't totally settled from the new PC. I'll get there. There's only a week left anyway, so. Okay, I'll try that again. Hi, everyone. I was just running through the lecture chat very quickly. What's the good question, Nicholas? What did Nicholas ask? How many students usually get a HG or D in COMP1511? I could get the data from last term, actually. I don't mind sharing that. I don't know it off the top of my head, though, because I didn't teach the course. But in theory, it should be... HD should be fairly low. D could be fairly high for 1511. Yep. Okay. All right. God, the chat's really... What's happening? Chat, you're all very social. Okay. So what's the plan? Yep. So mystery lecture. So we did some revision last time. We did another language. Yep. You're all okay with that. A bit of admin stuff. Okay. So today what I wanted to talk about is ways to support you with assignment 2. And then next week we'll focus on the exam. Keyframe frequency error. Okay, I don't know what that is, but I'm assuming the lecture is okay. So talk about a couple of ways that we debug our programs, and maybe these are things that will help you with assignment 2. So that's the first component of the lecture. Then we'll do general revision again. Like I said, we've covered all the actual concepts that you need for 1511. And so we have a bit of movement and freedom around what we talk about for the last few lectures. I got some lecture feedback that someone said that it feels like we've run out of content. It's not that we've run out of content. There's always a million things we could talk about. What I want to do is give people the space and time to consolidate on the concepts that we've covered, because we cover them quite quickly, apply them in assignment 2, and get ready for the exam. So it is intentional. And if you're interested in more concepts, the good thing is this is the very first course in a huge series of amazing computing courses. So there's plenty of content coming. But I do get the feedback too. It's a balance. So that's what we'll talk about today. So I fixed the lecture code location. So that should be in the week 9 directory from yesterday. And the code today will go there too. You should all be able to find that link by now. And I assume Tammy or Patrick is going to post the link as well, as always, and thank you in advance. Once again, I've already apologized in advance. We're going to be hammering this really hard. But my experience survey, please, it's gone up a few percentage points in terms of responses, but we'll be driving this primarily next week. But please, even if you get the QR code, scan the QR code, open the URL, and just bookmark it, and then when you've got some time, just to complete the link. We don't have the link in Moodle, so you just click that link. Again, someone will post it, and then there's the QR code there. So I'll leave this on. Probably helps if I move. I just maybe broke something, but that's fine. Okay, minimize this. All right, that's probably long enough. Oh, God. Oh, my God. Sorry. Okay. Didn't we already do this? Did I go back? Yep. Oh, my. It's ridiculous. Okay. So, sorry about that. Revision classes. What's going on with this? We're going to run a couple revision classes to support you getting ready for the exam. So what are they? They're not help sessions. So help sessions are one-on-one help, as you should know if you've been using them. So you drop in, you wait in your queue, and you get some one-on-one time. These revision classes, think of them as a cross between help sessions and tutorials. So we're going to get some amazing tutors to run a few sessions on specific topics for the exam. So what I wanted to do is to, as always, have you drive what these revision classes will cover and how they will be covered. So I'll show you the questions. I mean, you can click the link and see them anyway. So there's only 2 questions. It'll take you a second. So what topic would you like to see covered? That's pretty straightforward. You can type your own. Oh, that's not how you spell enums. You can type your own question as well. And what I'm really curious, this is an optional question, but what I'm curious about is how you can have your voice on how the actual sessions are run. So lecture style, so maybe the tutor standing up in the front of the classroom and going through the topics. Tutorial style, which is what you're familiar with, like hands-on activities maybe, or maybe some small group sessions or some new ideas. So if you've got any ideas on something different or just what you think works for you in terms of how these help sessions run, please let us know. There's already a response, that's cool. I won't open it. But yeah, please let us know. There's the link once again, and I'm assuming there's a lot of forms today. It's basically forms week, isn't it? Here, I can get the URL here. That's the link to the form there. Oh, I hope that link is actually correct. But anyway, I've posted it in the chat. Okay. Linked lists are fun to work on. That's awesome. Linked list by yourself. Yeah, linked lists, yeah, they're pretty cool. Someone said it in one of the previous lectures, but when it clicks that like out of just pointers and memory, we're able to create these custom structures as a person. We'll have a couple of streams. So don't worry about that. Just let us know the topic and the style. And we'll do maybe 1 of each or 2 of each or something, whatever we need to do. Okay. Any questions on that? Or that's pretty straightforward? Should be a bit like that. Okay, I'm going to assume that that's okay. And as always, the help sessions are still running and the tutorials are still running this week and next week. Okay, that's all for admin. 17 responses. Thank you for completing that. I really appreciate it. Okay. So like I mentioned, what I wanted to talk about this week, excuse me, are ways in which we as programmers solve problems, specifically when we're stuck with a bug or some logic that maybe we don't quite understand. And there's more than one way of doing this, and everyone's got their own everyone has their own style. So I want to take you through 2 of the big ways that I think developers in C-style languages, procedural style languages, debug programs. Start off with a really small example. Maybe we can come up with a more complex example to really demonstrate the value of when it's getting too complicated. But also show off some really simple debugging that's just outsourcing. Okay. Oh, and the other thing I wanted to talk about, let me just get that up. Let me get this up. Zoom in. Okay. If you're using VS Code, how many of you are using VS Code, by the way? How many of you have switched over to using it either on VNC or locally with SSHFS? Yep, a couple of you using it. Have it, but don't use it. VLab. Remember, you can use VS Code in VLab. Yeah, exactly right. So remember, you can use VS Code in VLab, right? It's on the machines, so you can still use it. But yeah, it works well on VNC. Yeah, I agree. What I wanted to show you, right? So if you go to Preferences and go to Settings, you can see this Settings page here. If you go to hold on, this is just showing it a bit weirdly. If you search C style in the settings panel and you go to C++, and remember, you should install the C++ extension if you're going to be writing C++ code. And if you change the C++ claim format style to Google, I've just changed it in both of these fields, it will actually, because if you start using the auto formatter, you'll notice that it wants to do this. If I format with these settings set to Google, it'll format it like, like we want you to in the course with the curly bracket on the same line. The reason why this is called Google is that this is how Google decided that it would like its C programmers to write C code. So it's commonly referred to as the Google style. There's lots of different styles, but we're happy if you use the Google one. So it's just a quick little thing that might help you if you've not bothered to change it. I'm pretty sure someone posted it on the forum and it reminded me to talk about it. So thank you, whoever that was, if you're in the lecture. If not, I'll take the credit. So yeah, you just install the C extension, search C style, and it'll come up. And you can just change that to Google. So that'll make your life a tiny bit better. I can zoom in once more. I can put this down here. Might be a good spot. Maybe here. Nicholas, what difference does it make? The thing is, it doesn't pick up any errors and doesn't give you warnings. Yeah, it doesn't. So it's not going to revolutionize your life. You're still the programmer in control of your development and your development environment. But I mean, I'll show you some of the stuff that it does, that it helps us do. Like I mentioned, right? So if we've got if we've got a function, like int double number, int, x, return x times 2, and then I put up a comment here, for example, this function doubles an integer passed in, returns the doubled integer. I know this is a really trivial example, but if you go to call the function, for example, double number, maybe I give it x here. If you look here, when I hover over the function, it's displaying that. You can't see. I don't know why I'm pointing. It displays this comment that was existing above the function, and so this function could be somewhere else, and it's a nice way of helping us get an understanding of what these functions are doing without jumping around our code. You can imagine in a bigger file, for example, that would help. So that's not any special extension. That's just the C++ extension. I try and keep my extensions fairly minimal. Okay, well, that's not that minimal. But in terms of what would actually be applied here, I just use the C++ extension, and I use the GitHub theme for VS Code. That's pretty much it. You can use DCC with VS Code if you're running it on VLab, or you're using a Linux machine and you're able to install DCC locally. There were no slides for the lecture yesterday, Justin. Yeah, so use SSHFS and you'll get VS Code over VLab with DCC. It's a nice experience. I probably should set it up, but yeah, and get the C++ extension pack. That's the only one you really need. This one here. Okay. All right. In VLab, it should just already be installed, Daniel. All right. So what I wanted to do was to look at the code that we've written in lectures in the previous few weeks and pick one out that we we'll talk about it, but we'll apply our debugging techniques to that file. But actually, in the meantime, let me show you with a really minimal example. This style isn't actually exactly perfect, but because if it's one line, it looks like it puts it on one line, but that's okay. Yeah. So maybe there's another style name that we should be using, but it's fine. You usually won't have one-line functions anyway. Once you've got multiple lines, it's correct. All right, so so let's say this function is something that returns that. Let's get rid of this. Add two numbers. Some really trivial example. Int result is equal to x plus y, and then we return result like that. So one of the ways that we can debug our programs is with nothing extra, and it's basically just called we just use printf statements. So you probably naturally started doing this, and it's a completely valid way to debug our programs. And basically what it consists of is just if you're at this point in your function call, we don't have double numbers anymore. If you're at this point in your function call and you're thinking, what's the value of what's happening here? Okay, this needs to be 2, it looks like. Whatever. And you're thinking, okay, what's the value of result here? Well, pretty simply, we can just printf %d \n result. And when we run the program, that's nice. Oh yeah, okay. This is add two numbers now, x and maybe 6. We could just do something like that. That works. Let me hide this. Let me do this, and I might just zoom out once. Is that still visible, hopefully? Or what I could actually do, is that better, do we think? You guys can let me know. That might be better. That's more like what we used to do in the lectures as well. Okay. When we run the program, we get the number printed out. Which is now, obviously, why is this printing out 1? Who can tell me? Why is result the value 1? Yeah, well, result gets assigned here, but why is result to the value 1? It's just, that's right. That's right, Cyril. We didn't assign it a value, so it's just got some random value. So if we change it to 0, and we compile that again, and we run that again, now we'll see that it's actually initialized to 0. So by using the printf statement, we can understand the current value of our variables as long as we understand where that printf statement aligns up to. One thing that sometimes happens is that we put too many printf statements in our programs, and then we run them, and then we actually lose track of which is coming from where, and it gets really messy. But for small programs, printf statements are a really simple, easy, tidy way of just inspecting what's going on and fixing maybe an issue that we have, or just understanding our programs. Okay, well, so some of you are sounding a little unsure about what happens to results. So this is another thing we do is, okay, let's just print it again. And something that you'll see you'll see us do is put like something like, you know, some marker so that you know when it comes up, you know where it came from. So you can see at first it was set to 0, and then after we actually assigned the addition to the result, okay, now it's set to 11, which is what we expect because it's 5 plus 6. And so that's the value that's going to get returned. Does that make sense? So printf's really simple, really clean, easy. You don't have to do anything. You don't have to think too hard. You can scatter them in, put some sort of marker, and run the program, and then see what's going on, see how some variable is changing as we run it. And you can imagine that as the... Okay, Matthew, that's a great point. Sometimes it's not clear where our programs are crashing. So by scattering the printf statements around, again, with a marker is really helpful. You know, this 1 or this 2. It can really help us understand where it starts to go wrong. So yeah, printf statements. See how it works. Great. The printf technique, exactly right. We should write these notes somewhere, actually. I'm just thinking. I need like a... Why don't we try something different? This might be risky, but it's gonna work. No. Okay, I'll do this after the break. I can't log into what I was trying to log into. Oh, hold on. Oh, there we go. One second, everyone. I can't do it. Never mind. I need a paid account. Forget about it. Ignore me. I'll write some notes somewhere else. So maybe in this file. Notes section for debugging. So printf statements help us, I like the C, into the memory of our programs. We can print out variable values with a marker to see where and what is happening. They are also good at helping us identify where a runtime error is occurring. Cool. So that should be all clear on the printf stuff. By bug spray. Okay. So let's copy this into a new file. I'll call it program2.c. All right. When we want to get more sophisticated, or when our programs are more complex, we have more sophisticated tools for debugging. So I've shown this, I think I teased this in one lecture, but let's do a really simple example. So if you install the C++ extension in VS Code, you can highlight just to the left of the number, these red dots will come up. You can click on a line to place one of these red dots, which is called a breakpoint. And we can place multiple, but for now we're just going to place one. And when you run the program through the debugger, so there's a few ways to do this. You can click this menu item here, and usually it should be able to set it up automatically for you. Alternatively, you can click this button here. And what it's going to do is really cool. Breakpoints don't happen in VLab, in VS Code. Okay, I might need to look into that. We'll talk about that later. But let's just have a look here, because it's a useful tool. As you go out of using VLab in the future anyway, it'll help you. And you can always get it set up, I'm sure. Maybe this is a bit easier. So basically what happens, you run the program through this mechanism, the debugger, and what it will do is we'll compile and run the program. So it runs line 18, it runs line 19, it jumps into the program, it jumps to line 9, and then it pauses. The program is actually paused, executing at this line. And what it actually gives us is all of the local variables and their value. So you can see result has the value 1 because this line hasn't actually run yet. So you can see its default value. X has the value 5, that's what was passed in. And Y has the value 6, again, that was what was passed in. And then what we can do is say, okay, we have a few controls up here that I think you can see, that can go away. We can continue, which will just run the rest of the program. We can step over the lines, which means run it line by line and sort of pause again. We can step into and we can step out to. I'll explain what those do in a second. And we can restart, which just compiles it and runs it again. But what it lets us do is track the value of these variables very precisely. So I can step over and you'll see that that result changed to 0 from 1. And in fact, it even highlights the number because it did change. You can hover over the variables and it will display its current value. So result is set to 0. I step over again. That line didn't change anything. It was just a printf. We can see result is still 0, X is 5, Y is 6. If I run this, we know that, okay, result should get assigned the value 11. Of course, that's what happens. We have our print statement there that we probably don't need anymore, and then we can return the result. We can step over, and you can see it brings us back to add two numbers. So it's also useful for really simply showing us the structure of our program. So, we call this function, it runs this code, it comes back here. So it sounds like it's not working properly for you. Is anyone trying running VS Code directly in Tiger VNC? Does it work there? Could someone let me know? Maybe, or Tammy or Patrick, if you know. So maybe just for SSHFS it doesn't work, which I didn't know about, unfortunately. While I'm waiting on that, something else that's cool, so I just reran that, we get back to this breakpoint. Okay, works in Tiger VNC. So maybe if you're really stuck on a problem, you can run it in Tiger VNC, run it in VS Code, debug it there. And that'll be a way to get sort of unstuck. Something else that the debugger is really good for, that print statements, while you can figure it out maybe, are a bit harder to figure out with, is the call stack. So you can see this down here. So the call stack, we talk about the stack, right? We talk about stack frames. You call a function, it gets a stack frame, it gets some variables. The call stack actually shows us that stack. So it shows us we started the program, we called main, and main called add two numbers. And it's showing you it's literally physically showing you the stack. And the really amazing thing is that you can change where you are on the call stack to see what its stack variables are. Isn't that really amazing? So with this revelation, I want to show you something really cool that we've been talking about. It's a bit topical. So let's stop this. So int x equals 5, add two numbers, x is 6. So let's actually change this to be, change x. We pass in x here. All right, let's delete this. Let's delete this. This is going to be change x. I pass in x. Maybe we can say int result is equal to that. And then we can say, printf, whoops, %d backslash, whoops, result. Okay. Happy with that. And then what we do here, why has this done this again? What we can do here is say x is equal to x plus, 2. We can just do something weird. X times equal to 2. Let's make that void. Let's not change it. You might get where I'm going with this. Okay, so what's going wrong here? Okay, yep. Let's do this. So this is a common problem that programmers make. I know we're talking about this a lot lately. You can probably maybe figure out what I'm talking about here. But if I clear this, if I compile this, whoops, program2.c, program_gdb, I renamed it. Okay, and we call program. You can see x is 5, even though when I called change x, I wanted it to do something to x. Remember? Now we know that, okay, this function probably needs to return x, and then we can reassign it to x. But let's say I just made this mistake. What the debugger lets us do is figure out what's going wrong. So I can set my breakpoint here to change x. Or actually, let me do this. Let me just set it to the first line in main. The program runs. We get our breakpoint initially. We're in the main call stack. We have one local variable. It's initialized randomly to x. We run the first line. It changes to 5. Okay, we're happy. We call change x. Now, this is what the step into feature does. So it steps into the function that gets called. It doesn't just step over and step past it. So I can click step into, and now I get into change x. And this is where we can illuminate what's going on. We're in the change x stack frame, right? It has a local variable called x. If I look at the main stack frame, it also has a local variable called x. And this is why people get confused, because they think, I have this integer, it's called x. I never made an integer up here. So x should be 5. When I run over the program, x is changing to 7 in the change x stack frame. But if we click back on the main stack frame, x never changed. Why is that? Oh, yes, of course. When we pass variables around, we pass a copy. And here we can physically see that there are two x variables here. Right? And as it's changing here, it's not changing in main because it's a different variable in a different piece of memory. I wonder what this does. This would be, let's have a look. I've never actually seen this. It's going to do something. I guess it's showing us the actual memory layout. I don't know. Let's not worry about it. Cool. So again, we change that line here. We manipulate the number again, but once again, back in main, it's not changing. We step over and that stack frame gets deleted and main's still back at 5. And then we go, okay, I get it now. So either I need to return x here, make it an integer and assign it back. Or what we can do, what's the other way that we can fix this problem if we really didn't want to return something? Like maybe we had two integers here. Yeah, exactly, Nicholas. So we could use a pointer. We've spoken about this too. So I make this a pointer. And I've got to get the value of x everywhere. Like that. And I've got to pass the address of x here. Okay, so let's stop that. And we'll run it again. And we'll see what changed. So we come to the first line. We get this integer called x. We assign it to 5. That's all normal. We step into this program. And what we see now is that x is not an integer. It's a pointer. And it's pointing to the location in main where that integer was declared. So that when we change the value of x, okay, the pointer doesn't change. But look at that. Look in main. The integer x in main is pointing to a piece of is stored somewhere in memory, and that memory location has been passed into this function. So as this function changes the value of that pointer, it's updating in main. So if I change it again, we can see that that's now changed to 14 in main. So when I print it, it will be 14. So that's just to show you how the debugger is really, really useful at helping you debug your programs. So we could, and maybe we'll do this if you guys want to, but we can run this debugger, for example, in a linked list function that's a bit confusing, oh, excuse me, and see how the function's working, what all the values in the functions are, and all of that stuff. But does that make sense? Can you see a lot of value here? Let me go through the lecture chat a little bit. AR11, why are we using a pointer? Oh, yeah, okay, fair enough. I can. We're just saying that you don't have to use it. Obviously, you would not use a pointer to do this. It was just to show you that the debugger, you would probably, this function would probably do this, right? This is probably how you would solve it. But there are cases where this won't work. So, for example, if you had multiple parameters here and you want to change x and y, for example, if they were pointers, then they would both change. But you probably get the idea with that. Why is the pointer symbol the same as the multiplication symbol? Great question. If only we knew and we could go back in time and make it not that way. That would be nice. Wouldn't it? How do you get the boxes with the pop-up when you hover over your code? Remember, you just need to have the C++ extension installed and enabled. Do you have that, Matthew? As long as you've got that, it should work. Epic. Awesome. Any questions? So if you're curious, the way this is, like I said, if the extension's not working over SSH, you can try run it in Tiger VNC. So you can just open Tiger VNC, connect. Oh, thank you for putting that. Oh. That was lucky. because I just typed my password into the username field, but you couldn't see. That was wrong. Okay. That was very lucky. I would have had to change all my passwords. That would have been a nightmare. So what you can do is open up Tiger VNC, open up a terminal, code program.c. That opens up Visual Studio Code in Tiger VNC. Right, so this is one way that you can do it. And then you can open up extensions, search C. And then you can install, hopefully, C++. Sure, I'll trust this. Yeah, Gabe, there's a new environment being deployed slowly across CSC in Tiger VNC, or on the machines. So there's an updated environment getting deployed. Okay, so that installs C++. We have our program here. Oh, wow. This must have been when we were writing. Oh, this is the web page program. This actually might be not a bad program to do some debugging. But again, we can find main. Oops. Here, I can set a breakpoint here. Hopefully, I've not tried this. Might need to make this zoomed in a bit. Save that. Debug that with... so it looks like we would need to actually add DCC as a compiler. But let me just try it with GCC. Okay, there we go. There's an issue. That's annoying. What if I just do here? Debug. Open a folder. COMP1511. If I just open this, trust it, sure. Program.c. Okay, int main, int x, set a breakpoint, run this with user bin GCC. What if I try that? Cool, there we go. So that's working. Yep, didn't I already do that? Okay, cool. So int x equals 5, x plus plus. Put a breakpoint there, for example, save that, run that. There we go. Cool, so there you go. So this is how you can get it working today with no extra work, and you get the x is 0 there. You get the call stack here. It's all really nice. There is a way to get it working with DCC, but I'm not going to worry about it. So does this help everyone, hopefully? So hopefully, the reason I'm talking about this today is so that if you're coming up to errors while you're working on assignment 2 or you're writing code generally, give the debugger a go. How to open it? Good question. So if you have a program on the command line, you know how you type gedit? Oh, you've deleted your message, but I'll keep talking. You know how you type gedit and it opens gedit? You can type just, whoops. You can type just code and it opens up Visual Studio Code. Or you can, it's exactly the same. So you can give code and then the path to a file, for example, and it will do that. Awesome? Happy? So I guess my challenge to you is if you're working on assignment 2 or anything really, give the debugger a go. Even if you don't actually have a bug, I don't know, there's something really fascinating about inspecting the state of our programs. Yeah, you should be able to run the VS Code as well. It'll just probably be in applications, right? Maybe. Applications, that's right. Accessories, no. Development, Visual Studio Code. So you can just open it that way as well. Or yeah, there's many ways to open it. Cool. All right. So do we want to debug a linked list program, or do we want to do general revision? What do we want to do? Yeah, we'll take a break. No worries. After the break. We'll say after the break. I can do a VS Code sort of overview thing. That means we can open our gedit file that we've... Yeah, absolutely, Alyssa. So remember that... So, for example, here there's a file called program.c. That file is just a file in the computer. So we can open gedit to open program.c, but we have to do that weird ampersand thing at the end. And we open up the file in gedit. It's just a text editor. Or, and then I gotta quit it, or we can use Visual Studio Code, a different text editor, to open that program.c, a more modern text editor, and we get all the features that we've been talking about with the debugger and the built-in terminal and things like that. So they're completely interoperable. You can use one, you can use both. I'll write up a Kahoot as well. But after the Kahoot, you're a Kahoot frenzy. You got stocks in Kahoot or something. So yeah, what we're doing, when we run a line like this, what we're doing is saying, open this program, so either code or gedit or whatever, and pass in the path to a file, and it'll just open up that file in that program. Yeah, so gedit is just an application. In fact, I can just open it from here, development, and then one of these will be... No, gedit probably comes with the operating system, so it might be here. Yep, gedit. So it's just an application. I mean, you can tell it's not the command line. It's a graphical interface. The stonks, yeah, the Kahoot stonks. And the terminal is just an application too. Yeah, the whole exam will be a Kahoot. Every time I do a Kahoot, I get a payout from Kahoot. All right, this has probably been long enough. What is path? Which path? Do you mean this? Everything is up. That's right. Everything. Someone wrote some code to write up these programs, and we use these programs. All right, 60% want to debug a linked list program. Awesome. And then 40% revision. So I propose we'll do a bit of both. Quick break. Kahoot, linked list debugging, which will turn into some revision, and then general revision. Does that sound like a good plan for the rest of the lecture? Okay. What is the path? All right, this is a good question, actually. I'll talk about the path. The path. Okay. So there's a bunch of programs on these machines, right? Like gedit, like code. These are programs on the computer. How does the terminal environment, so this application, know that when I run code, that it should open this application called code? So how does it know that? And you can imagine, right? So let me give you another concrete example. So this is a program. Agreed, everyone? I wrote a C file. and I compiled it into an executable. This is a program. But if I type program on the command line, that doesn't launch my program, right? And we don't want it to. I mean, I could compile 50 programs called program. Program is not on the path. That's what the path is, the mystical path. This binary is not on the path. Therefore, the terminal environment doesn't know about it. Whereas code is on the path. What does that actually mean? What is the path? The path is basically a string, and we can inspect it by typing echo path. And this is my path on this computer. So what this is saying is, it's a separation of paths, of directory, of paths on the machine, separated by colons. So there's 3 on the path here. Or 4, sorry, 5. And basically any application in any of these directories is now discoverable to the path, to the terminal. So basically what this is saying is that in one of these directories, Visual Studio Code exists and gedit exists. But for example, program does not exist. So what that actually means we could do is add this directory to the path. That didn't work. How do I copy this? And so we can say export path equals this directory. Oops, I think I need to wrap it in quotes. I'm just double checking on Linux how we do this. This directory and the current path, so that they're both there. And then if I echo the path, whoops, you can see that that directory is now also on the path. Therefore, if I just type program, you can see that actually ran this program. Isn't that cool? Unfortunately, the program didn't do anything, but we can do code program.c. We can, print f %d \n. We can, what we could do? So like, hey, Jake, thanks for running this program. Have a nice day. I'll just give myself a nice little thank you message. Oh, and I just gotta do that. Do that. We can quit code. We just need to compile it. Whoops, DCC program.c -o to program. And then I can just run program. Which means I could cd home. I can get out of this directory, right? Where there's no program, and I can just run program because it's on the path. It's discoverable. And if I've got multiple programs in that path directory, they'll all be discoverable and runnable anywhere. So you could have your own directory of your own programs, useful programs that you write, put them all in there, and now anytime you're in your terminal environment, you can see what's in there and you can run these programs. So if I'm really, for example, I could do, whoops, oh, that's it. We don't want to do that. Oh, you get the idea. I could move program to be like Jake hi. I think I can do this. And then I can just run Jake hi. All right, so I could go anywhere. So if I'm ever feeling, sad, I can run my little program there and get a nice little welcome message. And the path comes pre-configured with all the useful, did I just break something? I might have broken something. Oh no, it's uppercase. All the useful programs that come with Linux usually exist in these directories. So these are the directories of applications that Linux is shipped with. Yeah, thank you, Lan. Cool. And the other alternative is you put your applications in one of these directories and then they become discoverable. Oh. Yeah, that's right, Patrick. There's a lot of nuance there. So what happens if you've got multiple programs in multiple directories on the same path? You run the program name. Which one runs? The answer is just the first one. So the first program the first program it finds in a directory on the path is what's going to execute. But hopefully you learned something interesting there about how Linux works. Mac OS works the same. The path is just the path to the program. Yeah, exactly right. It's the path to the directory of where all the programs exist. And you can have multiple of them. Yeah, that's right, AR. Well, it's not a path to the program. It's a string containing a list of all the directories where your globally executable programs exist. That's the more precise way of saying it. So any program in any of these directories will be discoverable. Yeah, don't question the path. Linux and Windows and Mac OS, which is BSD based, work like this. Windows has a crazy complicated path thing that's a nightmare. But it works similarly. There's a list of directories where programs can be found. And if you think about it, it sort of makes sense that when you don't need, all of these programs to be on the path, because you're telling it exactly the path of the program that you'd like to run when you run it from the GUI. Yeah, we don't talk about Windows exactly. All right, let's do a quick break, quick Kahoot, and a couple more pieces of content. Cool. Who is Reed? No, it's the name of the. Oh, go get your car, Windows. It's the I don't know. Tammy or Patrick might have some more context, but it's just the name of the server, I think. Don't join the lecture in the car, Windows. Yeah, it's not a human name anyway. Okay. Sorry. It used to auto switch my mics when I changed scenes, but it's not set up properly. What I was saying was that, full disclosure, I didn't write this Kahoot, I found it. But it was the only one where the questions looked somewhat interesting. Brian Kernigan, shout out. Yeah, I don't know why it's called Read either. No idea. All right. What was I checking? How many people are here? Okay. And who we got in there? 30. Final week, sad. That is sad. Dennis Ritchie, Andrew Redmayne, CS Sushi, classic. A chair reveals Sleepy. The top looks like an Aaron. I don't know what that means. You lost your phone? That's not good. Oh, Aaron chair. I don't know. What's this brand? I don't think it's that. I don't know. You probably can't see. It's a decent chair. Decent office chair. Office staple, corporate life. Oh, okay. Yeah. Patrick, you're right. And then it's the same as the lab rooms. They're all named after musical instruments. Okay, yeah, let's go. Or like they're musically inspired somehow. Okay, which of the following cannot be used as an identifier? We're not going to do 19 questions, don't you worry. Do I need to hide my... There we go, just in case. Ooh, interesting. That's interesting. So you can't have a quote character in a identifier name, but you can have all the others. We're not going to do 19 questions, but we'll just stop at 5 or 6. Okay, what's the output of this program? I hope there's enough time for this. Oh yeah, it's 30 seconds. That's good. So I'll stop it when we get a lot of answers. Ooh, people are taking their time. You gotta read the code. Execute it. Okay, well done. That's good. That's tough. Yeah, good. If 5-1 close, 3 close. Yep. Oh, Trey back on top. Who is? Someone's going to tell me. At the end of the course, you got to tell me who's doing it. Or maybe it's like your copycat killers. So it's people changing it up every time. All right, what's the output of this program? Okay, well done if you had hello, hi. The 10 of you that got thrown off by the nasty if statement, yeah, a bit of a trick question. So the if statement didn't have brackets and it had a null terminator at the end, the semicolon, therefore, the terminator character, so therefore it just ran both lines. Oh, we lost Trey. Heartbreaking. Okay, this quiz is good. So I need to have harder questions, I guess. All right, here's another tricky one. Only 20 seconds. Damn, you got to be quick. You got to be quick. Mute that. Okay, yep, well done. I mean, it's not too hard to look. You just see that the y was just an integer, so it's going to print an integer, and there's only one integer there. So you didn't even need to compute it. You just should have picked the integer. But it's tricky. Yeah, okay, the stream delay is hard. Okay. You gotta be quick. Some of them were 30 seconds, I thought. All right, last couple. Find the output of this program. How would that work, Gabe? Unless you've got... That means you're just not at the start of the stream. So maybe you just need to forward. Maybe that's the problem. Anyway. What have you got? Ah, well done. 17 if you... Why was include help not the correct output? Because if you remember, it wasn't a string. There was no quotation marks. So it would try and think that it's a variable name, but it wouldn't be a variable name, so it would fail. Do you want to do one more? We'll do one more. Yeah, no quotes, exactly right. Return 0, still on top. Last one. Which special character can be used to separate two words of a variable identifier? 4 more. No, come on. I don't know. Never seen ampersand spelled like that. Wow, that was quick. But you all got it. Yeah, underscore. That's right. What did that do? Shrey fell off. Probably from, I'm going to assume it's the stream delay. But yeah, we're going to stop it there. How do I do that? End now. Duplicate of programming in C. Ina. See a sushi. Well done. And return 0, I think, was coming up on top. Yep, well done. Was the stream, was it too fast? Was that the problem? Yeah, GG. GG, well played. Okay. Okay, bye Kahoot. That can go as well. Yeah, it was too fast. Sorry about that. Yeah, that was hard. Okay. All right. Okay, what I wanted to do is copy this. Web, or just, yeah, web history. .c, history.c, and 9.2, paste it in, save that there. Oh, Cam, yep, thank you. Put that like that. Okay, so we'll do a quick bit of debugging with a linked list program, very relevant to what you're doing in assignment 2. So we can pick a function that causes a bit of headaches, but that's not too complicated. So maybe, well, it's also got to be one that gets called. Yeah, so size of linked list, for example, is a good one. So we can find where it's defined, which is here. We can set a breakpoint here, anywhere we want in our program, for example. Now, to give you a recap, size of linked list is called when we're going forward in history, because we're finding the maximum number of nodes that it can reach, or that exist in the linked list. What size of linked list actually does is just iterate through all the nodes in the linked list here, incrementing I each time and returning I. But what it can be useful at showing us is how it figures out, or how this while loop mechanism works. So, all right, so we set the breakpoint, we look at main, we know main's doing some stuff. I can't remember exactly which version this is, if it's the fancy version. I think it might be. Hopefully it actually runs, I don't even remember. Actually, this could be an old version, we'll see. But that seems to be okay. So it's calling the size of linked list function, so it's pausing the execution of the program at the point at which this program gets executed. And you can see our stack frame. And this is really nice. So it's saying we started at main. We can actually jump and see. Let me just make this a bit nicer. We can see at what line it was that we launched off this stack frame. So this function did not call size of linked list, right? It's not called size of linked list. But size of linked list called, main called visit new web page, which called insert node at position, which called size of linked lists, right? So we're following the stack frames to find how we got to this position. And once again, if we visit these stack frames, we can see the variables that we have, even if they're a struct. So Visual Studio Code is really nice at giving us a graphical explanation of the memory. So you can see history is a struct. It has a linked list, which is a pointer, and it has an integer. We have input, which is the string we used, the input string. That's just what's in main though, right? When we go to visit new web page, we have a different stack frame, so different set of variables. Insert node position, you can see all of these current, previous, all the variables that we're going to declare in the function. And when we get to size of linked list, we see the current values in the stack frame of size of linked list. So you can see we've got this head pointer, which is pointing to a node, and head pointer is currently set to null, right? So this is potentially before anything has been added to the list, which must mean what it is because it points to nothing. So we run this, we assign current to also point to null. So current is going to be, that's the memory address that current is pointing to. We assign I to 0, and we have an if statement. And so we say, is current not equal to null? Now, current is equal to null. How do I know that? Well, the null pointer is just the zeroed memory address. So when this line is executing, it's basically saying like, is current pointing to a zeroed memory address, pointing to null. So what I would expect is that when we execute this, the while loop doesn't even run. So what do we return? Well, we return 0 because there was no node actually at the pointer address that we were passed in. So this function is going to return 0 in this case. So what I could do, be like, okay, that's all good. I understand that. I can continue running. And it might be that our program actually has an issue. Or I can't remember what version this was actually. Oh, it's actually waiting for input probably, isn't it? It's waiting for us to input the name of the node, and I can't remember how to put that in. There's sometimes a way to get input into it, but it can be tricky when that happens. Enter string into terminal when we're debugging. I'm assuming, so if we pause it, I'm assuming, yeah, so we're at a scanf. So it's waiting for text to read in. I'm just trying to remember, yeah, there should be a debug console, but maybe when I moved this, or maybe I hit it when so let me just stop this. And let me compile this again. Okay, it just wasn't open. So let's continue that. Okay, now it says enter the URL, so I can actually enter text in. So I don't know why it was disappeared. Maybe for now, I'm just going to put this back here. But if you just search debug console, make sure that the debug console is open. So you can see it's running through, it's doing the printf statements, and it's doing even the scanf. So I can enter the domain, like Google. Unable to do this because the program is running. I'm sure there's a way. And where's the terminal gone? Nope, that's not right. I'm sure you can do it here. If anyone knows, maybe let me know. Yeah, I'm in the debug console. Okay, it might be that it's not configured correctly. It might actually work in... It might need some configuring, actually. Let me quickly look at something. Okay, I'm not going to do this now. Let me look into it after. There's a chance that on Tiger VNC it's set up. Let me look. Okay. My notification sounds are playing. Yeah, I can't turn it off, unfortunately. Sorry about that. Okay, I didn't trust it, obviously. Manage. Trust it. I think that'll let me then do it. All right, let's just try this quickly. Sorry about the delay. Okay, breakpoint there. Run that. Let's do it with this. Okay, that should be setting up. That's fine. We run that again. Now I think, and also let me just make this bigger. Okay, enter the command. I type Google. There we go. So on VLab, it's set up correctly. There's a bit of configuration. A JSON file is a file that stores basically configuration in this case. So there we go. I entered Google. Now it says the URL is google.com, and we come back to size of linked list. And now this time, things are looking different. So head pointer points somewhere. It's pointing to a linked list. And currents uninitialized, that's fine. I is randomly initialized. Something interesting here, if you're paying attention, right? This I, because we're in a different operating system, a different environment, the way it's initializing values is different. So I was initializing to 1 often previously on my Mac. Now it's initializing to something else. So this head pointer is the address of the first linked list. And you can see its next address is null. So it's a linked list with 1 item in it, which makes sense. And it's got the Google array. That's pretty cool. And it's got the HTTP google.com in the URL. And then again, we can run through this. Yeah, they're garbage values. That's exactly right, Gabe. It's just whatever data was in that piece of, at that memory location. C won't spend the time clearing it out for you, basically. But DCC sometimes does. Then you can say, well, is current, right? So is this pointer address equal to null? And in this case, it is not equal to null. So this is true. This is going to execute. We're going to change current to now point to the same location that next was pointing to. If we were paying attention, that's null. So current's going to change to point to null. So we've moved forward. We add one to I as well. We step over. We come back to test the while loop. So it's really good for showing us the control flow of our programs. Is current not equal to null? Well, that is null now, so that won't run. That means we looped once, so I will be 1. Okay, we have 1 element in our linked list. We run that again, and it's going to ask me what do I want to do? Forward, back, visit a new web page, or quit. So when we hook it up to the terminal, it's really nice because I can go, okay, I want to visit a new web page. We come back here, we'll skip over it because we've not done anything interesting. Enter the new website, cs1511.com, even though that's not a real website. We get back here, we can see, okay, well, what's head pointer pointing to? Some location. It's got some data. It points to something now, right? So it's really helpful for having us inspect linked list programs as well, because we can see where it points to null and how it's linked up and what's going on. And we expect we can set a breakpoint here, remove this one, continue, that I should return 2. And that is what it returns because there's 2 elements in our linked list. Whew. So if you've got a function that's messing with you and you don't quite understand or something's going wrong, play around. It runs beautifully here. So open VS Code in VLab, set some breakpoints, and go for it. Have some fun. Any questions on debugging? And we can just exit that. Have some fun. Yeah. Well, it's all relative. Yeah, no bug spray. Does anyone know well, at least what's passed around as the origin for the word bug? Why is it called a bug in our programs? Nice bit of computing history. Can you explain more about the call stack section in debug? Absolutely, we can. Because bugs are ugly. I don't know if it's, I don't know if it's 100% true. Yeah, that's right, Gabe. Yeah, and Elvin Seed. So I think it was Grace Hopper? Which is what Hopper is named after, the queue that we use. So Grace Hopper was one of the most important computer scientists in history. 1947. Back then, computers were massive machines that took up the size of rooms. You've probably seen that before. But there was literally, I think it was a moth. There was literally a bug in somewhere inside the computer that was causing. She's actually described it here. I can't really read it. Started cosine tape, sine chest with anyway, but it just caused something to not work. You can see an article here. So someone's asked, what did Hopper do? So she was a mathematician. I'm just sort of reading this actually, but worked on early abstractions of programming languages, what we take for granted now, that we write C code, and even C, it's plain English, right? It's it, while, if, something like that. I don't think it broke it. I think they fixed it. Daniel. And those massive computers were programmable, absolutely. So the tape that ran into those computers contained the instructions for how to move the bits in literal physical tubes or something like that. However it was that they were storing state, they would flip the bits to do calculations. They were programmable machines. If a computer's not programmable, it's not a computer, really, sort of. You can have set computers that do one thing, but they can run programs, and those programs mean that the computer is programmable. So anything that runs program is obviously programmable. So, and I think this is why we call it debugging. Obviously, a bit of a throwback. Yeah, punch cards is another example. It was just a way that was how we interfaced with the computer to change the bits in memory. The way we did that was making physical cuts that were being scanned somehow. Then it went from punch cards, then it went to tape, and then we went all different. Then we would type in instructions, and then it just evolves at a crazy pace, and we're still part of it at the moment. Okay, the call stack. Let's have a look. I'll do this example again. Oh, that was the wrong one. So just make sure if you do GCC on VLab. All right. So the call stack is showing us, right, when main calls. So the program starts at main. This is the first line that runs when a program executes. It calls the second line. It calls the third line. It calls the fourth line. It calls the fifth line. Okay, the sixth line. This is a function call that we wrote. Therefore, we need to execute that function call. So when we execute that function, we jump into the function to its first line. And we have on this stack frame, right? On this call stack frame, all the variables that exist. And in this case, actually, there's only one struct called history. Then if this function calls insert node position, we jump into that stack frame. So, and in memory is all the different data that across these multiple stack frames. So it's just the order in which functions were executed to solve the program. A punch card is part of the final exam. I'm sure I'll get questions on it if I joke about it, so no. Although it's pretty cool, isn't it? Direct electron manipulation. Exactly. Quantum computing. Oh, welcome back, Windows. You got your car. That's nice. So we're just talking about... are you the one that asked the question, Yujing? Hopefully. Oh, yeah, it was you. Perfect. Yeah. So it's the order at which it's called. Now, why is it called a stack? Because when we call a new function, it gets stacked on top. When the function ends, we go back. So this is also how it knows where to go back to. So some people have asked, like, how does a function know, right? Once you get to a return statement, where do you get returned back to? Well, when you see the stack frame, it's really simple. What do? So this function, this stack frame here, this call stack, is going to return a value. In this case, it's returning 0. Where's it going to return to? We often say that the answer is whoever called the function or something like that. But the way the computer keeps track of it is just, well, if I delete this stack, the top element on the stack frame, it's whoever is now at the top. It's insert node. That's exactly right. It pops off that stack frame.
I'm not sure I
My
understand.
goodness. Thank you, Siri. It pops off that stack frame and returns the value to whatever called it in the new top of the stack. So basically what it actually does is it takes this value, puts it in a special piece of memory that this one goes back into. Yeah, so it's not main, it's just the next stack frame at the top. Yeah, that scared the crap out of me. I should really just take this off when I'm teaching, because teaching's a violent affair and the watch is going nuts. I should track it as a workout, see how many calories it burns. And we can see this, right? So if I continue one more time, okay, one more time. Okay, we're now back at insert node at position. This function executed, the result got printed, and we go to the next line, and that stack frame is removed. Yeah, and it's deleted. That's exactly right. That's exactly right. And all the data in that stack frame is deleted. This is what, when we do the whiteboard stuff, we see that by just deleting the segment that had the box. And eventually, hopefully, we get back to main, we return all the data, we do the things we need to do, and our program continues. Amazing. Awesome. Yeah, so seeing the stack frame is really cool. It's a nice way of... This is why I like Visual Studio Code when you're learning to program, is because it does some help at illuminating what's happening in the memory and the stack frame and the call stack and the local variables in a function, you know. And you can even really, if you're really keen, you can see all the registers and how they're divided. Although it looks like it's getting a bit complex here. I don't know even what some of these are. But the CPU registers are basically the machine code that's being executed. Yeah, it is a pretty cool tool. Whew, okay. I'm getting worked up. Okay, let's just quit this. Okay, cool. All right, I think that's enough on debugger. Registers is like memory underneath C. So it's like the memory of machine code. There's future courses that you'll learn all about that stuff. Different operating systems, different CPUs have different machine code instruction sets, Gabe. That's what different, that's what the CPU architecture refers to. AMD, ARM, x86, they are CPUs that have different sets of instruction. And that's the big difference between RISC and reduced instruction set computers and complex instruction set computers. So the amount of instructions that a CPU can run and can optimize is all defined that. And so therefore, if you take this C program and you compile it to different architectures, it will actually create different organizations and use the available machine code instructions that different target architectures have. But this is well out of the scope for 1511. I think it's computer systems or whatever the next Tammy or Patrick will know. Computer system 1521, or is it something like that? 2511, that you learn all about this stuff. I can't remember the name of the course. 1521. Yeah, exactly. We're just using them here and sort of talking about it just a tiny bit. Okay. It's 4:50. We have another 5 minutes. We can why don't we just do Q&A, ask some questions about things that you want to talk about for the either assignment 2 or the exam. And we'll just do a bit of Q&A for 5 minutes. Does that sound good to everyone? Hopefully you found the debugging stuff useful. My idea was just that you would be able to use it for assignment 2 and your revision for the exam. So hopefully you all found that useful. Of course, let me know in the lecture feedback. And I'm conscious that we're really asking you for a lot of feedback, but yeah, I mean, you usually have the link to the lecture feedback at the end of the slides. I can paste that in now, if you like. Whew. Okay, coffee setup. I already said, Matthew, that you have to beat last term's my experience response rate to get the coffee setup. We're currently sitting at 8%. Last term, they reached 75%. So we've got some work to do. We have some work to do. I think COMP1511 will also go to GDB. Yeah, I think so, Tammy. PC specs, I just am now running off a M1 MacBook Pro 2021 or something. And I'm shocked by how fast it is, actually. Okay, I'll fill it in. And then now, not that one. Let me send actually, this would be a good thing to do. Let me get my experience. Okay, that's the revision classes form here. Yeah, 8.1, exactly right. That should be HBS, hopefully. My experience. Actually, I should not type it there. .unsw.edu.au. Let me just make sure that URL is correct. I think it is. There we go. Hopefully that link works. Oh, thank you, Patrick. Sorry. Alrighty, let's go. Q&A. F gets. Tammy or Patrick, do you want to give that one a go? Or anyone in the chat, actually, that would be good. How many languages will we know by graduation? Great question. I mean, it completely depends on what courses you take and what extra stuff you want to do on your own. But I was listening to a podcast. I can't remember what it was called now. Or maybe he asks, I don't know, I can't remember now, but they were talking about how many programming languages that a programmer should know. And I think they came up with some answer of about 3 or 4. But it completely depends on you and what you do and who you are and what you're trying to solve. And some people are really dedicated to one language and they want to do everything in it. For me, it's like languages are just a tool. And you can sort of use any language to solve any problem because they're all Turing complete, so they can all do everything. But some languages are just structured in a way that really help us solve specific problems. And so I love picking up a new language and just having fun with it. I barrack for Carlton, but I'm not a big AFL supporter, Gabe. What about you guys? What is life? 42. That's the answer to that. That was easy. No complaints on the course except for my bad schedule. Yeah, that's unfortunate. But you're dedicated, so that's what matters. What's the best way to learn programming languages in our new time? Find a problem that is suited to the language. So I'll give you an example. A lot of people want to play around with writing a web scraper, right? So a tool that can go to a website and get the data, bring it back into the program. So use Python for that. You're not going to want to do that in C. That would be an absolute nightmare. So find a problem suited to that language. You've done 1511 almost. So you're programmers now. So find a problem and just start writing. I mean, everyone's got a personal style, but that might be one way of doing it. Okay, the questions are actually coming in quite fast. So I think that's a nice way. Have I ever done CS50? No, I haven't, but I've looked at some of their stuff and I'm jealous of how well produced it is. How many languages families do you know? Mostly procedural, object-oriented, a tiny bit of functional, a tiny bit of logic, paradigm stuff. City Swans, of course, yes. Write an AI and take over the world. Well, probably Python. Python's everything for AI at the moment. Yeah, Project Euler is really good for getting really optimized algorithms, I think. Yeah, web scrapers are fun. Why don't we get in touch with for but the while loop? Yeah, it's a bit of a good question. Historically, this course doesn't talk about or allow the for loop. I'm a little personally less opinionated about it, but I understand completely the reason for it. The reason, pretty simply, is that with a while loop, you have to initialize I on the line before the while loop. You have to increment Y in the body and makes it very clear that this increment happens after this line. It makes it clear that this I exists in this scope, right? Not this scope, right? That's better. Is this still running? Yeah. And so you have to be a bit more explicit, and it's a bit clear what's happening with the structure. When you use a for loop, which is what most programmers will use for this sort of program, or it might be, or you could, I is less than 5, I plus plus. Right, this is how most people will do a counting loop. So these are, well, not in this case, while do something and then I plus plus. So these are equivalent. They do exactly the same thing. But do you see with the, God, I can't type. With this example, it's a lot clearer if you don't know what program, if you're new to programming, it's a lot clearer that this I gets defined here. The loop starts here. I is here, for example. It gets incremented here. Now, the for loop is just saying, well, it's really common that these three components need to exist in a loop. So it has a nice syntax for it. It's on one line. But it's not as clear that this I gets created, where it gets created, what scope it's got, and all of that sort of stuff. So that's the reason. It's just a choice that we've made to try and make things a little more transparent as to how the stuff's working. It's really not a big deal, though. Skyscrapers are trying to take the sky, exactly. Are there any subjects in Python, or is it too easy? Oh, it's not that it's too easy. 1531 used to be in Python, but what you'll find right after 1511, after maybe the first 2 programming courses you take, courses shouldn't, and they don't teach programming languages. They teach you ideas and concepts and use an appropriate programming language. So it's not, you don't need a course to learn Python. I mean, you should be able to, after some time, maybe not just yet, go out and learn it yourself. Have I played around with CUDA or OpenGL for compute? Not really, but I used to work on NUMA architecture computers, which are high core count. I mean, it's different from graphical. That's an awful article about it. Different from using GPUs to do processing, but NUMA, I think our servers used to have 64 CPUs or even double that. And it's a different memory architecture for doing high performance data computing. But I've never actually done CUDA or OpenGL for compute. But I guess if you use like machine learning stuff, they're often using it under the hood, but not directly. Then there's Python for loops. Yeah, they're a totally different beast. Yeah, exactly. Yeah, I used them a lot before I actually understood how they work. That's exactly what we're trying to avoid. We want you in 1511 to understand everything. And while loops are doing a few less things than the for loops, which mean they're easier to understand. But you won't be marked down for using them, Elvin said. Was that RuneScape? I didn't even see it. Okay. Yeah, that's right, Patrick. Yeah, Patrick said it. Exactly right. So I don't mind the idea. Cool. All right, any last questions? Otherwise, you know the spiel. My experience survey, please do it. We really care about feedback in this course. I hope I've shown you throughout the past 9 weeks that we care about feedback. We make changes because of feedback, and this is a formal way of doing it on top of just the that stuff. And then I've already spoken about that. And I don't have a lecture feedback form, but I think I already sent the list around to it. So no, that's okay. Did you have an old Newgrounds account where you put Flash games? No, I never actually made any games with ActionScript and Flash. I was just, I don't know why. It was a weird environment, but I think I just had Flash and it had a language in it, so I just wanted to play with programming. But I never actually made Flash games. It could have been fun. Yeah, please do my experience for us. Yes, thank you, Tammy. Thank you, Patrick. Thank you, Joe, AR, Windows. I'm glad you got your car back. Thank you, everyone. Have a lovely week. Good luck with assignment 2, as per usual. Any issues with your assignment 1 mark, just let us know. We'll help you through it. Any ELP special considerations for the assignments for the exams, let us know, as usual. We're almost there. Can you believe next week will be the last lectures we have together? How heartbreaking. We will talk about the exam. I'm sure you're all keen for that. And we will wrap up your first computing course at UNSW. How sad. But bittersweet. Yeah, I don't want it to end either, but it has to. Okay. All right. Have a lovely week. Thank you, everyone, as per usual. And I will see you